Okay, and welcome to the final case study. So we're going to look at Markov chains, and we're going to look at one of the classic uses of Markov chains, which is a thing called pagerank. So think about what this is. So a setup. Imagine I have a very simple internet. So here you can see we have 4 web pages. And what we've got here is I've labeled the web pages 1, 2, 3, and 4. And an arrow means that there is a hyperlink, a link from page 1 to page 2. Again, we've got a link from page 2 to page 3, etc. And we might want to rank these web pages on how important they are. I mean, this is, PageRank was the foundation of Google. So how does it do it? Let's imagine you've got a drunk surfer who randomly clicks a link. Where will he end up most of the time? So you just go to a web page, you're drunk, you hit a link, you go to another web page, you just keep cycling through that. Where are you going to end up most of the time if this is your internet? Because then we can rank those pages according to how often people end up there, how important they are. Well, first of all, let's look at the one-step transition matrix. So here we have ours. So we've got, for example, from going from state 1 to state 1, well, there's no links to itself, and then it's got a 1 in 3 chance of going to all the rest. So because they're randomly chosen, if you look at state 1, he can go to 2, 3, or 4, and we're going to assume that these are equally likely. So we've got this, and I want to find out the long-term behavior. So what's the long-term behavior of this? Well, we're going to look at our equilibrium distributions. So let's go and have a look at it. Here's my code. Here's my matrix. So first of all, we'll set up the matrix. Let's have a look at that matrix. So there's my transition matrix. And we know that we want the left eigenvalues. And to do that, we're going to use eigent. And we want the one associated with the eigenvalue of 1. So it's the first one. So I'm going to take the first one. I'm going to normalize it. And so we find that this is the proportion of time it's going to end up. So it's going to end up approximately 16% of the time in web page 1, 22% of the time in web page 2, 27% of the time, and 33% of the time in web page 4. So that's our values. Do we believe it? Well, I went and checked that. So what I did is I wrote some Judeo code. So if you don't know Judeo, Judeo is a nice little open source code out there, and it runs really quickly. So here's some code that's going to run this DTMC, this discrete time Markov chain. It just quickly simulates through them, and then I'm going to export that out so I can look at it in R. So if we run that code, it takes about approximately 2 seconds, and at the moment it's doing 10 to the 7, so that's about 10 million steps. Not too bad for 2 seconds. So if we go back to our code, we're going to read that in, and we're going to see what values we get, and you can see the proportion of the time is roughly what we got with our actual analytic version. And here's a plot. You can see that the majority of the time I end up in state 4. Okay, so that's a rough indication of PageRank. Let's do it for something interesting. Let's look at Eurovision voting. So Eurovision, if you don't know it, and I have to ask why don't you know it, you should be watching it. But let's assume you don't know it for some reason. Basically, every country in Europe, including Australia, which obviously is a famous country from Europe, they send over a singer who sings a song, and every country then votes on what their favourite song is in a particular year. And you give points. Each country will give points, but the top point is 12 points. So if you give 12 points to another country, you're saying that is our top song. If you're interested, the data is here. So we're going to read this in. So if we go back and come down here, here's my spreadsheet of the data. And when we look at it, what you've got is you've got the year, whether it's the semi-final, final, information about the edition, whether it's the jury or televoting, which country is given the votes to which country, and how many points they gave. So for example, in 1975, you can see that Belgium gave Ireland 12 points, the maximum points. So we're going to do a bit of cleaning here. What we're going to do is, first of all, we're only going to focus on the finals, which are indicated by an F. We're only going to look at people who gave 12 points, and we're going to look at the year, the country and from, and then what we're going to do is we're going to count up how many. So we end up with something like this. So you can see, for example, twice, so there's 2 years where Albania gave Australia 12 points. Albania gave Bosnia and Herzegovina 1 point, etc. So we've got all that. So let's have a look at this data. Quickly run the previous steps. Bit slow today. Really slow today. That's good. So we've got our edges, and what I'm going to do is I'm going to create a network for this. So in my network, every node is going to be a country. An edge will indicate there's been at least one time that a country has given another country 12 points. And we're going to add a weight. We're going to add a thickness to that depending on how many times they've done that. So we create ourselves a little network. And we'll have a look at this. And you can see that, you know, we've got our nodes. Here's the names. And we indicate that there's an edge between them. So we can have a look at this. So here using gggraph, so you can see all your countries. Let's zoom in. And you can see the various countries and you can see edges between them. It's not particularly good. So I went to Gephi, which is a data visualization, and produced a slightly better plot with some tinkering. So here's the picture we have so far. And here's the picture after I've cleaned it with Gephi. So let's see what we've got. Well, first of all, you can see that I haven't spent a lot of time cleaning this data. We have the Netherlands here and the Netherlands here because someone's entered into the spreadsheet it wrong. But never mind. Let's see if we get some interesting stuff. So first of all, if you know Eurovision, you will know that basically every year Cyprus and Greece give 12 points to one another. So you got this big, huge band. And you start to see there's a lot of politics associated with this voting. It's not really about the best song. So you can see this is all about the fact that these have a strong political connection. Russia. Let's look at the countries that are associated with Russia. You've got Azerbaijan, Belarus, Ukraine, Estonia. These are all were part of the Soviet Union. They're strongly related. We've got Albania and Greece have a strong connection between them. And then Albania and Macedonia, again, neighbours. Now you've got the Yugoslavia. So it started when Yugoslavia was Yugoslavia. Then they split up and then they support Montenegro and Serbia, giving a lot of votes. You've also got this whole sort of Baltic states, Norway, Sweden, Denmark, passing a lot of votes. United Kingdom used to get a lot of votes, but since probably Brexit started, that's really dropped off. We now don't do very well at all. Ireland is getting a lot of the European countries. Iceland and Denmark have a lot of connections. You can see this thick line. Any other ones? Spain and Portugal, a lot of connections. Moldova, Romania. So a very political type system. But what's the one you're going to end up the most? If you were randomly chose a country and then you went to the next one by following their votes, giving more basis depending on whether they voted more, where would you end up? So we're going to do that. What we're going to do is we're going to do a page rank. So I've got the nodes and I'm going to do the page rank. As I said, it's very common. It's built in where we've got the weights. Here's the weights. And we're going to have a look and see which is most likely. So let's have a look. In fact, I've got this already in the other picture. So there we are. We find the most highly sort of central node when it comes to PageRank is Sweden, then Russia, Ireland, and then Greece. Now, if you know anything about this, you know that Sweden is common. You notice Australia is quite low down. Where is Australia? I did find it earlier. We're quite low down. There we are. But then again, that doesn't surprise you. This is since 1975. We've only been part of Europe in terms of Eurovision for probably the last 5 years. So not bad. And obviously you see some other countries that have only really been a country recently, since the 90s. But why Sweden? Why is Sweden doing so well? Well, probably because of this. They are renowned for producing great, great songs. They get beyond the politics. Obviously, they get a lot of support from the Baltic neighbours. But they've had ABBA and a lot of other classic things. So there you are. There's a classic example of a Markov chain used for something very useful. In fact, it's $1 billion algorithm, if you think about it. A Markov chain, because Google made their fortune on PageRank. And there's a nice indication of now you know that Sweden is probably one of the most central countries when it comes in terms of voting in Eurovision. Hope you enjoy that. See you next time.